You're looking for the fastest, simplest, and least expensive way to get a web server up and running. Your big dreams will not be held back by dinosaur technology or layers of abstractions. You want to be nimble, build fast, and ship faster. If you're a developer/engineer, you know it's important not to over-engineer things. A famous guy once said, "Simplicity is the ultimate sophistication." And there's really nothing simpler than a Nitro server and a Postgres backend hosted on Railway. So that's what we're going to build in this video. Ready to get started? Let's go. To kick things off, we're going to spin up a new project via npm using Gigit. Gigit? Gidget? I don't know. We'll use the Nitro template and call our project Intro to Nitro. Also, let's install the dependencies. We'll need the PG package and its types since we'll be using Postgres. All the packages are in place. Let's jump into VS Code. Database support is still pretty fresh, so it's hidden behind the experimental flag. Our server needs to know how to connect to the database. You can define both a dev database, which will be used when running in dev mode, or another database when running in production code. I have a local version of Postgres running on my machine, and I have an instance of Postgres running on Railway, so two configurations here. Railway specific configuration requires the private network hostname and port 5432. If you're using something else like Neon, this will look a little different. The Postgres DB0 connector has an open issue right now, so before we continue, we're going to need to patch it. Waiting for open source PR merges is a bad idea, so let's just unblock ourselves quickly and move on. Open up the package JSON and add a post install step. We'll also need to install the patch package dependency. Now, let's fix the issue and create a patch out of it. During deployment, after npm install, we'll run npm post install and then npm build. There's a reason these are experimental features. That's it, we're done here. Let's get to actually building our API now. To store data, we're going to need some tables in our database. Creating these can be done inside a Nitro plugin. Let's create a plugin directory and then a file named 01.c-database.ts. Plugins are executed in order, so if you want one plugin to execute after another, you would then add 02. and 03. and so on. All we need to do here is create the table if it doesn't exist. If you want to seed some data, you could put in some insert statements here, but we'll skip that because we'll be adding our own way to add data via the API. Finally, we can add some routes. Let's start with get all products. Inside the routes folder, open up the index.ts file. Let's add some boilerplate in here. This is essentially a function which handles the request coming in. Routing in Nitro is file and folder based, so index.ts at the root of the routes folder is equivalent to just a / in the URL bar. Next, let's add the code to pull products from the database. There's no repository pattern here, no wiring up dependency injection or anything like that. You just pull the data you need via the SQL query from the database and return it. No need to manually serialize, Nitro does that for you. We could fetch all the products now, but we don't have anything in a database, so it's not going to return anything. Let's fix that. In the routes folder, add index.post.ts. We're already familiar with the request handler boilerplate. We want to read the body of the incoming request, and if it exists, we'll feed the properties into the SQL statement. Lastly, we return a 201 after the record is created. Now, if the body was missing or an empty string, we will return a 400. Next, let's create a delete route. In order to get a parameter from the URL, we'll encase the name of the parameter in square brackets. Nitro's naming convention and file-based routing is really pretty straightforward, and you can use all the common REST verbs. In this route, we're going to need the ID of the product, and we're creating a delete route. To get the parameter, use the getRouterParam helper and pass in the name of the parameter. This is the same as the name inside the square brackets. If the ID parameter exists, we use it in our SQL query and delete the record from the database. If not, we return a 400. Note that we haven't at all validated any user input in this demo. Typically in production code, you'll always want to validate input, especially if it's public facing. In JavaScript, we have a few options like Zod, Yup, Joy, and others. In Nitro, adding this kind of validation can occur either in the handler or in the middleware after path inspection. If this is something you're interested in seeing, please let me know in the comments and we'll make a video on that. Okay, great. Now we have a very basic REST API that took a few minutes to put together. Let's host it on Railway. Just like in the Next 3 video, we'll add a Docker file. But first, we have to make one small adjustment to our package.json file. Because we had to patch DB0 and we need to run the patch during build time, we need to promote Nitro pack and add DB0 as an explicit dependency. Now, we can add a Docker file and fill it with some commands. First, we define the base image we'll be building in. Then, your typical npm steps, and remember, we need to run the post install step to patch DB0. We build and prune. Finally, we copy the build output into the base node image and expose 8080 on the container. Railway uses 8080 as the default port and also passes that port in a variable down to the container. Alright, almost ready to deploy. Let's add a Docker ignore file, put in some defaults, and we're off to Railway. Assuming you published all this code up to GitHub, you're now ready to deploy on Railway. Let's create a new project. This will house our REST API and the database. Next, let's create the database. This will take a little while to deploy, so patience is advised. Great, now the database is deployed. Its private networking URL can be found here. It's the same URL we're using in our project configuration. The database is up, so let's create the service. We'll be connecting it to the repository in GitHub and deploying straight from the source code. There are no variables we need to set this time, so we can go straight to deploying. It will take a short while, but when it's done, we can create the public URL and test it out. Here, I'm using Bruno to make some REST requests. First, let's test get products. Obviously, nothing will come back yet since the table is empty. So let's add a product by sending a post request. The response is successful, so now get products should return at least one item. And here it is. Let's delete it. The ID of the product is 1. We can use that in the URL to make a delete request. And it's gone. And we got an empty array again. Great, that's it. And there you have it, a functional REST API built and deployed in under 6 minutes. Easy, right? Thanks for watching. I'll see you in the next one. Take care.